Now let's talk about the electronics on this guy. I was very not familiar with how to do much of anything with electronics or audio stuff before I started this. I have some experience writing code, mainly Python, but not enough to really feel comfortable that this is the right way to do things. So keep that in mind as you are watching this video. There may be mistakes I made or other ways that I could have done stuff better. I don't want to pretend that there aren't better ways to do any of this. This is just how I got it done. So as I said in the previous video, there's a list of all of the parts and components I use to do this in the description. So don't worry about keeping track of everything as we go. I started out my build with plans to just use the Arduino Uno board because that's what the instructions from the files suggested. I spent a lot of time futzing with that layout trying to get it all working, only to find out that it had several issues that just made it not work for me. I met a very smart, awesome dude named Matt who led me towards a better way and changed everything. So I'm going to focus on this better way and not talk too much about the other. The first thing you need is a list of all of the hardware. It's all listed out in the description, but I'm going to talk about a few key components here before we move on. When you look at videos of IG-11 from the TV show, you'll see that all three of his head sections are rotating at times at a full 360 degrees. I'm sure it's totally possible to get this working if you're an animatronics expert, but I am not. I found it getting very expensive and difficult to get it working, so I decided that since it's a prop that's just going to sit on my shelf and only be viewed from one angle, the 360 rotation part just wasn't that important. So that being said, for the servos, I ended up swapping out 2 of the suggested continuous rotation servos with 2 of these 270 degree standard rotation servos. The reason for this is that all of the continuous rotation servos I was finding did not allow you to control the exact angle that the servo was positioned at on any given frame. I wanted to be able to control the exact movement of each piece, and the only way I found to do this was with standard rotation servos. Next, regarding the LEDs. The WS2812B LED chips that work with the NeoPixel Arduino library are really cool. You can do a lot with them. But because of the way they are designed and the control they allow, they work with the board's interrupts in a very specific way that causes all kinds of other issues I had to work around. Specifically, they cause issues with the IR sensor. In my current build, when I press a button on the remote, the IR sensor misses the command a vast majority of the time. So I have to hit the button a bunch of times in hopes that it will eventually catch it correctly and trigger it. I read some info suggesting this was because the NeoPixel library isn't compatible with everything due to the way these interrupts are handled in the differing libraries. It was also causing issues with my audio at times, and who knows what else. So if you are knowledgeable about this, you can maybe find some LEDs that allow the same control but don't cause issues with your interrupt. Or maybe you can find some other control system for the IR sensor that can work for you. It could save some headaches, but my code has already worked around this as best I could, so you should be fine using a version of my code for your setup. For the LEDs, I just followed the instructions that came with the files for the most part. I soldered the chips together following the wiring instructions. I will say it was very helpful to put a piece of foam double-sided tape on my table and then stick the chip to it temporarily while I soldered. Also, make sure you measure each wire in between the chips. I accidentally made 3 of mine too short because I assumed they were all the same length, and I ended up having to redo them. I purchased some diffusion gel from Amazon to use for diffusing the LED lights. I ended up needing to do 6 layers of the gel in order to get enough diffusion. So if you find a thicker gel that will give you better results, you can save yourself some work. You can see here how I made little band-aids with the gel and some tape and then stuck them over the holes. When you start to cut your wires for everything, make sure you give yourself enough extra length at the ends of them. I didn't at first, and I ended up having to take mine apart to make some stuff longer. It wasn't a fun process. Here you can see an image of a setup I did for the ends of my wires. Since all of the red and black wires would end up in the same place, I made this connector wire that would allow me to funnel them all together and still connect and disconnect them at will. Ultimately, I ended up with 2 of these for each color, and it really helped out a lot. While we're on the subject of power, the Arduino Uno can power a small amount of stuff that you have plugged into it, but you can't do nearly as much as you will need. So I purchased this 5-volt power supply from Amazon. It made everything work much better. Ultimately, that single power supply is powering all 5 boards, 4 servos, the speaker, and the LEDs, and it's got plenty to spare. A couple more notes before we move past the assembling part. If you use the slip rings like I did, do not attempt to use the stranded wire for them. I couldn't find solid core wire at first, so I just stripped some of my stranded wire and used that. It worked for a bit, but once I started spinning the parts a lot, the rubbing of the slip ring contacts on the stranded wire started to fray it, and at one point, a piece of the wire crossed my connections and shorted out my I-tilt servo. It fried it, so I had to install a whole new one. So get the solid core wire or just avoid the slip rings altogether. I've included a wiring diagram that shows how I ended up wiring everything together in the description of this video. I'm not going to get into the details too much here because it will make this video way longer than it needs to be, but make sure you get that grounded wire from the power supply back to the Arduino. It's easy to miss and vitally important. Alright, that's it for this video. Last part, here I will talk about the code and how I got all of that working, so stay tuned.